What is the Earth structure?
The region that includes the Earth's crust and the upper part of the mantle is called the lithosphere. It has rigid, rocky outer layer of the Earth, consisting of the crust and the solid outermost layer of the upper mantle. It extends to a depth of about 60 miles. Continents and oceans are located in the lithosphere. According to the structure, the lithosphere is divided into continental crust and oceanic crust. Oceanic lithosphere is associated with oceanic crust and is slightly denser than continental lithosphere. It is bounded by the atmosphere above and the asthenosphere below. In the study of the structure of the Earth, we can find out the main three layers are crust, mantle, and core. Let's look up the crust. The crust comprises about 1% of the total area of the Earth's surface. Its thickness is not uniform and it is about 5 kilometers deep in the oceans and 60 kilometers deep in the continents. The uppermost thin layer of the Earth's crust is soil, which is constantly being developed by the living environment. This thin soil layer is important in agriculture. According to the density of rocks, crust can be divided into two main parts, which is continental crust and oceanic crust. The continental crust is also called the Sial layer because it consists of granite rocks. They are primarily composed of silica and aluminium. Oceanic crust is also known as the Simag layer. They are primarily composed of silica and magnesium. The primary rock layer that underlies the Sial layer is the Simag layer. The boundary separating the Earth's crust from the mantle is known as the Mohorovicic discontinuity. Let's learn about the mantle as a second layer of the Earth structure. The layer between the crust and the core is the mantle. The mantle is a layer that extends from the surface of the Earth to a depth of about 2,900 kilometers. About 2/3 of the Earth's mass belongs to this part. It can be divided into the upper part and lower part. The upper part consists of olivine and silicate and the lower part is made up with magnesium and silicate. The boundary separating the mantle and the core is called the Gutenberg discontinuity. Let's learn about the core as a third layer of the Earth structure. Core. The core lies below the Earth's mantle. It is the very hot, very dense center of our planet. The ball-shaped core lies beneath the cool, brittle crust and mostly dense mantle. The core is found about 2,900 kilometers below Earth's surface. Why is the Earth's core so hot? There are three main sources of heat in the deep Earth. Heat from when the planet formed and accumulated, which has not yet been lost. Frictional heating, caused by dense core material sinking into the planet's core, and heat from the decay of radioactive elements. The Earth's lithosphere is made up of many tectonic plates that are moving very slowly relative to each other.
What are tectonic plates?
The Earth's plates have been moving since 200 million years ago to the present. 200 million years ago, there was only one tectonic plate in the Earth, but at present, this tectonic plate has broken into 7 tectonic plates. The Earth's lithosphere is made up of many tectonic plates that are moving very slowly relative to each other. Accordingly, the lithosphere consists of 7 large tectonic plates and several small tectonic plates. These plates move due to the strength of convection currents in the interior of the Earth's crust and Earth's rotation. These plates are moving on the Mohorovicic discontinuity. Through the movement of these tectonic plates, the creation of new ocean floors, the creation of fold mountains, the creation of ocean trenches and the occurrence of volcanoes and earthquakes.
What is the theory of tectonic plates?
Plate tectonics is a scientific theory that explains how significant landforms are formed due to Earth's underground movements. The idea, strengthened in the 1960s, transformed Earth science by explaining many phenomena, including mountain-building events, volcanoes, and earthquakes. In plate tectonics, Earth's outermost layer, or lithosphere, made up of the crust and upper mantle, is broken into large rocky plates. These plates lie on top of a partially molten layer of rock called the asthenosphere. Due to the convection of the asthenosphere and lithosphere, the plates move relative to each other at different rates, from 2 to 15 centimeters per year. This interaction of tectonic plates is responsible for many different geological formations, such as the Himalayas mountain range in Asia, the East African Rift, and the San Andreas Fault in California, United States. The idea that continents moved over time had been proposed before the 20th century. However, a German scientist named Alfred Wegener changed the scientific debate. Wegener published 2 articles about a concept called continental drift in 1912. He suggested that 200 million years ago, a supercontinent he called Pangaea began to break into pieces, its parts moving away from one another. The continents we see today are fragments of that supercontinent. To support his theory, Wegener pointed to matching rock formations and similar fossils in Brazil and West Africa. In addition, South America and Africa looked like they could fit together like puzzle pieces.
How are the tectonic plates formed?
Starting roughly 4 billion years ago, cooler parts of Earth's crust were pulled downwards into the warmer upper mantle, damaging and weakening the surrounding crust. The process happened again and again, until the weak areas formed plate boundaries.
What is the tectonic plate boundary?
A tectonic boundary is a boundary between 2 plates. The tectonic plates move slowly and constantly but in different directions. Some move towards each other, some separate, others pass each other. Tectonic plate boundaries are grouped into 3 main types based on various movements.
What is divergent plate boundary?
Here's what happens. A divergent boundary occurs when 2 plates move apart. Here, magma from the upper part of the Earth's mantle comes to the surface and moves towards the ocean floor, allowing a new ocean floor to form. These often occur along mid-ocean ridges. Examples include the Mid-Ocean Ridge and the Indian Rise.
What is convergent plate boundary?
In subduction zones, a convergent boundary occurs when 2 tectonic plates are pushed together. When an oceanic plate and a continental plate collide, the oceanic plate slides under the continental plate and folds down.
What is transform plate boundary?
Transform margins mark slip-sliding plates, such as California's San Andreas Fault. The San Andreas Fault marks where the North America and Pacific plates grind past each other in a horizontal motion. The plates do not slide smoothly but build tension and release it in the form of an earthquake.
What are the main tectonic plates?
Pacific Plate. At 103 million square kilometers, the Pacific Plate is the largest of all the lithospheric plates. Specifically, it stretches all the way along the west coast of North America to the east coast of Japan and Indonesia. The Pacific Plate is almost entirely oceanic, except for the areas around New Zealand and part of California west of the San Andreas Fault. The Pacific Plate contains all 3 plate tectonic boundary types along its boundary. That means it shares convergent, divergent, and transform borders with other tectonic plates. This plate forms most of the Pacific Ring of Fire, which has some of the most violent and catastrophic earthquakes and volcanoes on the planet. It is a 25,000-mile string of volcanoes and seismically active sites that outline the Pacific Ocean. And smack dab in the middle are the islands that make up Hawaii. The interior hotspot within the Pacific Plate is responsible for the volcanic activity that occurs in the Hawaiian Islands. The Pacific Plate is constantly in motion. This nature of the Pacific Plate is believed to be responsible for forming the Hawaiian Islands. Originally, the Hawaiian Islands were volcanoes that formed above water over millions of years. North American Plate. With an area of 76 million square kilometers. The North American Plate is the world's second largest tectonic plate. The North American Major Plate not only contains the continent of North America but also part of the Atlantic Ocean. This plate extends all the way over the North Pole and even contains Siberia and the northern island of Japan. It also includes Greenland, Cuba, and the Bahamas. The edges of the North American Plate exhibit all 3 types of tectonic boundaries. San Andreas Fault, a transform boundary between the Pacific Plate and the North American Plate. Convergent boundary of the Pacific North American plate near Alaska. A divergent boundary in the middle of the Atlantic Ocean, where the North American plate borders the Eurasian plate. This also created the Mid-Atlantic Ridge, a chain of submarine ridges in the Atlantic. The interior of the North American plate contains a giant granitic craton. It's believed that the North American craton is 4 billion years old. Eurasian plate. Eurasian plate, the third largest tectonic plate, spans all of Asia and Europe. This plate is sandwiched between the North American and African plates on the north and west sides. The west side has a divergent boundary with the North American plate. The south side of the Eurasian plate neighbors the Arabian, Indian, and Sunda plates. The Eurasian plate hosts a plethora of volcanoes, triple junctions, seismically active faults, flood island basalts, and accretionary wedges. Its southern and eastern boundaries are the most tectonically active. The most prominent geological formation associated with the Eurasian plate is the uplifting of the Himalayas. The Himalayan mountain range is the result of the collision between the Indian plate and Eurasian plate, which began approximately 50 million years ago. On average, the Eurasian plate is moving away from the North American plate at a rate of 3 centimeters per year. African plate. With an estimated area of 61.3 million square kilometers, the African plate is the fourth largest plate tectonic boundary in the world. Africa was once the center of Pangaea, the massive supercontinent that existed about 300 million years ago. Since then, South Africa, India, and Antarctica have split away from Africa. As a result, the African plate has 3 mid-ocean ridges along the eastern, southern, and most of the western sides. The west side of the African major plate diverges from the North American plate. These divergent plate boundaries form the mid-oceanic ridges or rift valleys. The African plate seems to be splitting apart faster than what geologists have imagined. The East African Rift, aka Afro-Arabian Rift Valley, is the end result of diverging motion between eastern and western Africa. Antarctic plate. The Antarctic plate holds the entire continent of Antarctica, including its surrounding oceanic crust, stretching roughly around 60.9 million square kilometers. It encompasses the continent of Antarctica and further stretches outward under the surrounding oceans. This plate is surrounded by parts of the African, Australian, Pacific, and South American plates. Antarctica was once part of Gondwanaland, the southern half of the Pangaean supercontinent. Gradually, Antarctica split away from the other continents and moved southwards and reached its current location about 30 to 60 million years ago. It is estimated that the plate moves at a snail's pace towards the Atlantic Ocean, just 1 centimeter per year. Indo-Australian plate. The Indo-Australian plate is a major plate combining the Australian and Indian plates. But they are widely considered to be 2 separate plates. At about 58.9 million square kilometers, it is the second smallest tectonic plate on Earth. The Indo-Australian plate stretches from Australia to India. It also includes the oceanic crust of the Indian Ocean. The northeast side of the Australian plate converges with the Pacific plate. Australia, India, and Antarctica were once connected as the supercontinent Gondwana. As part of the supercontinental cycle, India drifted apart, moving northwards. The Indo-Australian plate is currently moving to the northeast at about 5 to 7 centimeters a year. One of the forces that drive the movement is the subduction along its northern sides, as the plate is subducted along the Pacific Ring of Fire. However, the upper mantle of the plate is moving at a slower rate, about 2 to 3 centimeters a year. South American plate. The South American plate, the smallest among the tectonic plate, covers 43 million square kilometers. It is a major plate that includes the continent of South America and a large portion of the ocean from the Atlantic Ocean. On the west side of South America, it experiences devastating earthquakes due to the convergent plate tectonic boundaries. But the eastern edge lies in the Atlantic Ocean at a divergent plate boundary. Alongside the African plate, these 2 plate boundaries pull apart from each other, creating some of the youngest oceanic crust on the planet.
What landforms are caused by tectonic movements?
A tectonic landform is any relief feature produced primarily by uplift or subsidence of the Earth's crust, or by upward magmatic movements. They include mountains, plateaus, and rift valleys. Erosion shapes landforms, and their origins lie in the tectonic processes that build the Earth's major structures. Geological processes mainly cause the uplift or subsidence of rock material, blocks, layers, or slices of Earth's crust, molten lava, and even large masses that include the entire crust and uppermost part of the planet's mantle. In some areas, these processes create high elevations such as mountains and plateaus. Others create tectonic depressions, as exemplified by Death Valley in the western United States, the Dead Sea in the Middle East, or the Turfan Depression in western China. Almost all areas below sea level have been created by tectonic processes. Mountain ranges and plateaus are formed by the uplift of the Earth's crust or by the displacement of volcanic rocks to the surface. Most mountain ranges consist of volcanic chains formed from rocks derived tens of thousands of kilometers below the surface. Some plateaus are formed by massive lava flows over a large area. In addition, molten rock can rise to the surface by seeping into the crust from the bottom. Many other ridges are formed by thrusting over one terrain or adjacent crust, another mechanism of surface uplift. Processes are the result of horizontal forces that cause crustal shortening and crustal thickening. Finally, the heating and thermal expansion of the outer 100 to 200 kilometers of Earth can turn vast areas into ridges or plateaus. Landforms primarily caused by earthquakes. Deep ocean trenches, volcanoes, island arcs, submarine ridges, and fault lines are examples of features that can form along tectonic plate boundaries.